Hi, my name is Sid, and I'm one of the three developers of Stroke Prediction. The reason that my team and I made this model is because of a couple of months ago, my grandma had a stroke. Fortunately, there was someone there to help her at the time, but after that incident, my family and I were really worried about what would happen if somebody wasn't there, and that we can't leave her unattended in the future. This is a common case for a lot of families who have a loved one at a risk of a stroke. So this is where our model comes in. It is able to detect whether someone has a stroke at any given time by tracking their face. And in the unfortunate event that they do, it will call 911 to the address of that home. This model will help families live worry free and reduce stroke fatalities by a large margin.
Good afternoon. My name is Venkatesh Kakalapu, and I'm one of the co-developers for the Stroke Predictor machine learning algorithm.
I'm Abhi Kurapati, another one of the developers in this program.
So to start off with our model, we're going to start off right in the beginning. Here we import some libraries, crucial libraries like CV2, TensorFlow, all that good stuff. Next up, we have to read all our data set. So our data set regards of a bunch of stroke and non-stroke data, which is a bunch of images with people's faces. Either they're having a stroke or they're not, and we receive this data set from Kaggle. So to read this data set, we need to have an algorithm which can analyze each one and then convert them to NumPy arrays so they work with Keras. That's exactly what we do here. We have the folder path. We then make a list for this folder path so that we can run a for loop. And basically, this for loop reads each image with CV2 and then converts them to NumPy arrays and has the corresponding labels within the list. Next, we also take that list and convert them to NumPy arrays for the labels. After that, we resize these images to 64 by 64 dimensions so they work within the algorithm. And after we do that, we convert these to NumPy arrays as well, so the labels and the images work properly. Furthermore, we have the label encoding sector, which makes these the right data type so they work properly and scaled properly for the convolutional neural network layers so they're processed on the right track. So that's what we do with these label encoders. And as you can see, we use the categorical method to make the num classes proper and convert these from 0 to 1, with dividing them by 255. After that, we have our CNN layers. As you can see, we have an input section of 64 by 64 because that's how we resize them. And we use ReLU as the activation function. And for the output layer, we use softmax. We then compile all of this so it's nice and set for the training part. Here we use our X-training data and our Y-training 100 data because we use the label encoders. And once we train that, we get to the testing section. We use the dot predict function, and from here we have what our machine learning model thinks or predicts the X testing data wide section will be. So basically the labels, and after that we print our accuracy. When we ran the model, we achieved a 98% accuracy, which is one of the highest accuracies you can receive for CNN structures. From there, we save our model and we move on to the input section so this can actually be implemented. Here we use the same exact thing. We have a file location for the images you would like to use. We read it, convert this to NumPy arrays so they can then be processed. Obviously resize the images as well, which we do before. And this is basically the same structure as our original model. And from there, it predicts the predicted label for that image, stroke or non-stroke. And from there,
For the model to work properly, we obviously need front-end processing. Our dataset from Kaggle had mainly zoomed in pictures of a human. So we found out that our model isn't very accurate when not a zoomed in picture. For that, we used a YOLO V8 model to find a mask of an image and crop into it. So we did that. We first started by importing all these libraries, importing the YOLO V8 model, and making directories or folders. Then we segmented and annotated this image, which basically means the model is predicting the frame, and then it's zooming into it. And then we just saved it to a different folder. and this folder is the one that our model will use. This is our live demo of our model, and it's about to show you the epochs and training, and then the testing right after that. So give it just a second. Yep. So now we're seeing the first epic run, and this one has like an accuracy of 69%. Second one, 83% accuracy. And we can see it going up now. With Epic is higher. And 94%, and the last epic will have 97% accuracy, and the testing accuracy is 96%. And the rest of our program includes our front end data processing, which we couldn't make work perfectly because of the virtual environment that we set up. But if we put an image there that we have right now, we have an image there, and so if I run this, it will take a picture of their head and put it into a new folder. Let's give it. Should work, and this is the picture that we got with it zoomed in, and this will help us run our program. And let me just do that right now. So it's running, and we will see the accuracies. And here it's showing a 96%, 99% accuracy of a stroke, which the person in the image does have a stroke, and it's showing a 3% accuracy of the person not having a stroke. So we can confidently say that the program is